Average slope. Let's do this for an example and in general. So an example, let's give me an example here. What do we have? Let's make a y equals x squared. Some other function. And we'll call it y of x. Oh, why did I call? Oh, okay. Well, the reason I didn't call this one here is this is the more formal notation of it, because I'm saying that this function here is only a function of x. If this also was a function of z or time, then I would probably want to write down y is a function of x and time and z, but it's only a function of x here. So, and because it was only a function of x, I just didn't write it down because this looks a little too cumbersome. Okay, but this is definitely the right way of writing it, and I just wrote down sloppily here. But in this case, I want to make sure that everyone knows that this is only a function of x. And here's my y. Okay, so I want to get the average slope. Average slope between where? I want to go this between 1 and 2. Okay, so that's between x equals 1 and 2. Well, we'll call this difference here delta x. And we need to figure out what delta y is, where this guy comes across and where this guy comes across. So how to do that is to plug it in here, right? So I put in x equals 1 into here. A 1 squared is y equals 1. So this is y equals 1. And if I put in x squared here of 2, I'm going to get 4. So y equals 4 here. Okay, so my delta y is equal to 4 minus 1 is 3. And my delta x here is going to be, well, 2 minus 1, which is equal to 1. So my average slope here, the slope between points 1 and 2, this slope here is going to be a rise of 3 for a run of 1. Okay, the picture doesn't do it justice. It looks like a 1-to-1 slope here, where really it should be 3 high and 1 over. Okay, so the delta y over delta x is equal to 3 between values x equals 1 and x equals 2. Let's do for a general case, and this is the one I'm really concerned about. So for a value of x, I know this is the x-axis and x shows up here. This is just telling people that this is positive x. But let's try for x, and over here we'll call this x plus delta x. So whatever the value of this was, if this was 1, plus delta x, well, delta x was 1 in this case, so 1 plus 1 would be 2. Okay, so this is the difference between delta x. This is x, and this is going to be x plus delta x. Okay, what do we do next? What did we do next? Well, I need to figure out what the y values were. So the y values here, well, this was, I just took this x and I put it into the function and it gave me the value. Now, I don't know what the function is here. So the best thing I can do is I can just write down y of x, because that's what I'm going to do. As soon as I know an x, I can put it into there and get my function, just like I did here. But I knew the function was. I knew the function was x squared, so I wanted to have x equals 1, so I plug in 1, and I would get y equals 1. That's why I knew the number there. But here I don't know what the function is, so I'm just going to put y of x. Now this one's a little more complicated, but this value here is actually going to be y of x plus delta x. Now, don't get too alarmed here, but this is just taking an input in. That's why we said this is a formal way of writing it. This is taking an input, whatever value of x, and I give my output. So my input here is x plus delta x. That is what the value is. Whatever, you have to tell me later on what x is and what delta x is, and then I can tell you what number that is. Once I have that number, I can put it into the y function, again, unknown. That's why this is the general case, because we just don't know it. It can be used in general for any function. We plug in x plus delta x into this function, and we'll get the y value. Then, how did we determine the slope? Well, we determined the slope by taking delta y over delta x, and that's what our slope is. Delta y over delta x. So in this case, delta y is going to be this y value minus this y value. So it's y of x plus delta x minus y of x over the run was I took this value minus this value, right? I took 2 minus 1. It gave me 1. So I'm going to take x plus delta x minus x. Well, I can see the x's cancel here. So I have like x plus delta x minus x. So the x's will cancel. And I'll just be left with, and I'm so sorry, this is written as delta, this should be written as delta y over delta x. So the final answer here for delta y over delta x in general for average slope is that. And hopefully we can understand what all these terms are. You have to give me a lot of information. First thing, you need to tell me the function and what x and delta x is, and then I can plug it into here and determine what your delta y over delta x is. But this would be the average slope for a given function. For any function, any general function, this is the equation right here for getting average slope.